Hyperbolas are everywhere. You may be wondering how hyperbolas could be all around us. Isn't that just something we could only see in a math book or a lesson in class? Well, you may not notice it, but a lot of things we see in our everyday lives are actually shaped like a hyperbola. But first, let us explain exactly what hyperbolas are.
Imagine 2 points, points F1 and F2. Now, consider having a point P. If you connect the points F1 and F2 to point P and get the difference of the shorter segment from the longer segment, you will get a value. Let's set that value equal to x. Are there any points like point P wherein subtracting the lengths of the segments would result in a value equal to x? Yes. If we plot all those points, we will get a graph of the hyperbola. If the value of the difference of the segments change, then we would get a different hyperbola. Given these premises, the formal definition of a hyperbola would be the set of points in a plane such that the difference of each point from two fixed points is constant. The parts of the hyperbola are the following: the foci, which are the two fixed points, the vertices, the transverse axis where all the points sit, and the conjugate axis. The standard equation of the hyperbola with the center at coordinates hk and the x-axis as the transverse axis and the y-axis as the conjugate axis is x minus h quantity squared over a squared minus y minus k quantity squared over b squared equals 1.
Now that you know what hyperbolas are, you must think, why is this so important? Well, it might be a surprise, but hyperbolas are actually everywhere. Have you ever seen this? This is actually called a cooling tower. Let's observe its shape. The bases of these towers are very wide, as these towers need proper support to be very tall to avoid fogging and recirculation as it releases vapors in the sky to cool down the fluid inside. Moreover, you can also see that the middle is narrow, which helps facilitate the rising of the vapors inside. Finally, you can see that the top is wide again, as this is where the hot air meets with the atmospheric air. And the wide opening helps facilitate the diffusion that occurs when the two mix. If you may have noticed, the shape of the cooling towers actually resembles a hyperbola. This is actually one example that shows how the hyperbola is useful in real-life applications.
Let's look at another example. Have you ever seen your favorite band or singer use one of these? This is a guitar, and its body also resembles a hyperbola. Guitars are hyperbolic in shape as it maximizes the structural integrity, tone, and balance while it's being used. Additionally, the shape also makes it more comfortable to use as the curves make it easier to rest on your lap. Now it's time for a fun fact. This tower is called the Kobe Port Tower and it's located in Japan. It is actually the first tower to have this hyperbolic shape and it was designed in 1963. It was inspired by the Japanese instrument Suzumi, whose shape also actually resembles a hyperbola.
Amazed? So are we! Hyperbolas are important not only for lessons in math but for real-life applications as well, such as engineering and astronomy. So, the next time you think about playing the guitar or visiting Japan and seeing the Kobe Port Tower, hopefully you remember and appreciate this particular lesson in math. This is Group 6 of Block D, and we hope you learn more about hyperbolas.